Hello engineers, this is a mechanical engineer, and in this video I will tell you how to calculate thermal efficiency, work ratio and pressure ratio of simple gas turbine power plant. And before you watch this video, I suggest you to watch my previous lectures on power plant engineering, so you can understand this video very well. So without wasting time, let's get started.
Let's take a look at this example. First, before I take a look at this example, I will draw here gas turbine. This is combustion chamber and this is turbine. This is compressor and this is combustion chamber. And this is turbine. Actually, I have already explained everything, but I am doing this so I can explain it very well. This is shaft between compressor and turbine. Air enters in the compressor with temperature T1 and with temperature T2 it comes out and go to combustion chamber, and then as T3 it comes out from the combustion chamber and enters in the turbine, and as T4 it get exhausted in the environment in open cycle gas turbine. So let me read this. In a constant pressure open cycle gas turbine. This is constant pressure open cycle gas turbine. Air enters the compressor at 1 bar with, so I will write here pressure P1 is equal to 1 bar, and then 18 ounce Celsius. So temperature will be 18 ounce Celsius. 18 ounce Celsius. And if I will convert it into Kelvin, then 18 plus 273 is equal to 291 Kelvin. And then where it is compressed to a pressure ratio of 6. So P2 upon P1 is the pressure ratio. It is 6. The gases enters the gas turbine at 730 ounce Celsius. So enters in the combustion chamber, enters in the gas turbine. So T3 it enters with the temperature of T3 in the gas turbine. So T3 will be 730 ounce Celsius. So 730, I will convert it into Kelvin from ounce Celsius. So it will be 1003 Kelvin. I suggest you to keep calculator with you so you can calculate everything easily. And it expand to the original pressure. Calculate the work ratio. I have to calculate here work ratio. And the thermal efficiency. I have to calculate here thermal efficiency. Where gas turbine plant operates on the Brayton cycle. And I have to assume gamma is equal to 1.4, specific heat capacity 1 kilojoule per kg Kelvin. I have done here some mistake. It's kilojoule. for air, and gamma is equal to 1.3, and specific heat capacity 1.1 kilojoule per kg for gases. Neglect the mass of fuel. So now I want to find here thermal efficiency and the work ratio. So what is the formula of thermal efficiency? Formula of thermal efficiency is net work done by the turbine, by open cycle gas turbine, upon heat supplied, QS. So first I have to find here heat supplied and net work done, and I have to also find here work ratio. So what is the formula of work ratio? Formula of work ratio is net work done by turbine, by open cycle gas turbine, and net work done by turbine. So this is the formula to find work ratio. So in both the equation I will need the value of open cycle gas turbine net work done by open cycle gas turbine. So, and I will also need the value of heat supplied. So what is the formula of heat supplied? So where heat gets supplied in the open cycle gas turbine, heat supplied in the combustion chamber. In the combustion chamber, fuel and gases get mixed and heat get supplied. So formula to heat supplied is QS is equal to specific heat capacity of gas into T3 minus T2. T3 minus T2, temperature of after gas turbine and before gas turbine. So do I have the value of T3? Yes, I have the value of T3, but I don't have value of T2, so I have to find it. So I will find it later. So, and I will also need the value of net work done. So what is the net work done? What is the formula to find net work done? Formula to find net work done of open cycle gas turbine is net work done by turbine minus net work done by compressor. So first I have to find here net work done by turbine, which is required here too, and I have to also find here net work done by compressor. So what is the formula to find net work done by turbine and compressor? Let's discuss that. Formula to find net work done by turbine is net work done by specific heat capacity of gas T3 minus T4, and formula to find net work done by compressor is specific heat capacity of air T2 minus T1, kilojoule per kg of air, kilojoule per kg of air. So do I have the value of T3, T4, T2 and T1? Let's see here. I have here value of T3 and T1, but I don't have value of T4 and T2. So I have to find it first. So what is the formula to find it? So I will first take a look at process 1-2, which is isentropic. So the formula is T2 upon T1 is equal to P2 upon P1 raised to gamma minus 1 upon gamma. So which values I have here? I have here value I have value of T1, so I will put here value of T1, which is 291 Kelvin. And what is pressure ratio? Pressure ratio is 6 here, so I will put here value 6. What is the value of gamma? It is 1.3 and 1.4. 1.4 for the air. Actually air is going to enter here, so I will take here 1.4 for the process 1-2. So 1.4 minus 1 upon 1.4. So I can write this equation as 291 into 6 into 1.4 minus 1.4. So now you have to use your calculator. As you can see here, I have got here answer 485.53. So I will simply write here the answer 485.53 Kelvin. This is temperature T2. Now I will take a look at isentropic process 3-4. So what will be the formula? Formula will be T3 upon T4 is equal to P2 upon P1 raised to gamma minus 1 upon gamma. So I want to find your value of T4. So I can write this equation as again so I will put here the value of T4, value of T3. What is the value of T3? Value of T3 is 1003 Kelvin. 1003 Kelvin. And what is the pressure ratio? Pressure ratio is P2 upon P1 is equal to 6. But here is P1 upon P2, so it will be 1 upon 6. What is the value of gamma? We are going to take a look at this process. So I will consider here value of gamma 1.3, particularly for gases, because it will be gas here. So I will write here 1.3 minus 1 upon 1.3. I have to calculate it by using calculator. As you can see here, I got here answer T4 is equal to 663.32 Kelvin. So now I got here the value of T4 and T2. So by using these two values, I can find the value of net work done by turbine and net work done by compressor. So first I will find here net work done by turbine. What is the formula? Formula is specific heat capacity of gas into T3 minus T4. So what is the value of CPG, specific heat of gas? What is the value of CPG, heat capacity of gas? I will take a look at heat capacity of gas because I am taking a look at this portion. So what is the value? 1.1 for gases. So 1.1. What is the value of T3? Value of T3 is 730 Kelvin. So 1003 Kelvin. 1003 Kelvin minus what is the value of T4 is 663.32. So I can calculate it very easily by using calculator. As you can see here, I got here answer 373.65 kilojoule per kg of air. Now I will find here net work done in the compressor. So what is the value? Net work done for compressor is heat capacity of air into T2 minus T1 kilojoule per kg. What is the value of specific heat capacity of air? It is 1 for air. 1. What is the value of T2? I have just found it few minutes ago. 485.53. 485.53 minus what is the value of T1? Value of T1 is 291 Kelvin. So I can calculate it by using calculator. So as you can see here, I got here answer 194.53 kilojoule per kg. And I have from the value of net work done by turbine and net work done by compressor, I can find here net work done by the gas turbine power plant. Net work done by gas turbine power plant is net work done by turbine minus net work done by compressor. So what is the net work done by turbine? It is 373.65 minus 194.53. So answer will be 179.12 kilojoule per kg. So I will also need the value of specific heat if I want to find here thermal efficiency. So now I will find here value of specific heat supplied. I have to find here value of heat supplied. Actually I called it specific heat by mistake. Actually it is heat supplied in the combustion chamber. So what is the value? What is the formula? Formula is specific heat capacity of gas minus temperature after turbine minus temperature before turbine, and the value of heat capacity of gas is 1.1 and value of T3 is 1003. What is the value of T2? Value of T2 is 485.53 Kelvin. So answer is 569.21. So I will write here 569.217 kilojoule per kg. This is the value of heat supplied in the combustion chamber. So what will be the, so now I can find here work ratio. What is the formula of work ratio? Formula of work ratio is net work done by the gas turbine power plant and net work done by the turbine. So what is the net work done by the gas turbine power plant? It is 179.12 kilojoule per kg upon 373.65 kilojoule per kg. I can find here by using calculator. So this is the answer. 0.479. This is the work ratio. Now I will find here thermal efficiency. What is the formula? Formula is net work done by the open cycle gas turbine upon heat supplied, which is W net upon QS. So what is the net work done by the turbine? It is 179.12 upon what is the heat supplied? It is 569.217. As you can see here, I got here answer 0.3146, and I can write here 31.46% is the thermal efficiency of this simple gas turbine power plant. So I got here the answer. This is the final answer. This is our thermal efficiency, and this is our work ratio, which was asked in the question. As you can see here, it was asking us what was the work ratio and what was the thermal efficiency. So now I will take a look at another example. A gas turbine installation work on Brayton cycle between temperature limit. I will draw here gas turbine power plant again, compressor, combustion chamber, and turbine. Temperature 1, this is the shaft between turbine and compressor. So what is the temperature limit? 35 ounce Celsius is lowest temperature and 715 ounce Celsius is highest temperature. So temperature from the atmosphere in the compressor is always lowest. So T1 will be 35 ounce Celsius. I will convert it into Kelvin, which will be 308 Kelvin. And T2 will be, actually T3 will be, because highest temperature will be in the combustion chamber, which is T3, and it is 715 ounce Celsius. I will convert it into Kelvin. Though it will be 988 Kelvin. For the maximum work to be developed, calculate temperature at the end of the compressor. So I have to find here T2. And pressure ratio. I have to find here pressure ratio, RP, and the thermal efficiency. So it want me to find here for the maximum work. I have to find maximum work. I have to find for maximum work. What I have to find? Pressure ratio. I have to find your pressure ratio. So pressure ratio for maximum work. So what is the formula? Formula is pressure ratio is equal to T3 upon T2 1 upon 2 gamma minus 1. So this was the formula which I derived in my last lecture, in my previous lecture. So what is the value of T3? It is 988, and I have to find your value of T2. Actually it is T1. T1 is 308. 1 upon 2 into what is the value of gamma? I will take here value of gamma 1.4 minus 1. So simply calculate it. Actually I have done some mistake. Actually it is gamma here, so I will write here again this equation 988 on 308 1.4. I will take here value of gamma 1.4 minus 1. Now I will calculate it. So as you can see here, I got here answer 7.688. This is the answer. This is the value of pressure ratio. Now I will find here temperature at the end of the compressor. Temperature at the end of the compressor, which is T2. So I will take a look at isentropic process. And formula is T2 is equal to T1 into pressure ratio raised to gamma minus 1 gamma. So this can be written as value of T1 is 308, value of RP is 7.688 raised to, I will take here value of gamma is 1.4 minus 1 upon 1.4. So what will be the answer? I will calculate it. As you can see here, answer is 551.62 Kelvin. So now I will find the value of thermal efficiency. I have to find here thermal efficiency. So what is the formula of thermal efficiency? Formula is 1 minus 1 upon Rp raised to gamma minus 1 upon gamma. This is the formula. And you might be asking, sir, why I did not use this formula which I was using in my last example. Actually in this example value of specific heat capacity is given, but in this example it is not given, but I have the value of pressure ratio, so I can find here by using pressure ratio. So that's why I used here this value. So I will put here the value 1 minus 1 upon 7.688 raised to gamma. I will take the value of gamma is 1.4 upon 1.4. So what will be the answer? I will calculate it by using calculator. As you can see here, I got here my answer. My answer is 0.4416. I can write it as 44.16%. So this is the thermal efficiency. This is thermal efficiency, and this is temperature at the starting of at the end of the compression, and this is the pressure ratio. So as you can see here, I have got here all the values here. So this is it for today. God bless you.